We definitely believe strongly that our units are some of the highest quality in the field, and we hope that when we cover this SAM 950 with you, or if you already have one, you can attest to the strength and the power of these units. So we're going to go ahead and transition into a quick video, and after the video, I will go ahead and let Mark Slattery go ahead and take it away. Right, here we go.
Speaker, power button, touch screen, handle button. The shoulder strap assists in reducing the fatigue for the SAM 950 end user. The SAM 950 can be mounted on a tripod for continuous monitoring. Applications include radiation monitoring, homeland security, emergency responder, and more. Depending on dose rate and threshold settings, the SAM 950 provides audio, visual, and vibrating alarms. It also assists the user with messages such as move forward, move back, in measurement range, and danger. A handle-mounted keypad provides buttons to easily operate the major functions of the application software. Easy thumb operation can be executed even when wearing gloves.
All right, that's one of my favorite movies. But all right, Mark. It looks like your mic is muted right now. If you can go ahead and hit
as
that
it
button.
should be.
And yeah, Mark, go ahead and take it away. I will go through the slides as you cover them, as well as provide live demonstrations of the unit.
Well, how can I top the movie? In fact, I think it covered everything so well that we're done, and you all have a nice day. No, we'll go into this because we promised that we would. What we're going to present today is a, well, first off, maybe just a little background. I'm Mark Slattery, the Nuclear Applications Manager with BNC. I've been Applications Manager for 12, maybe 13. I lost track. Maybe this is going to be my 14th year. We have done the SAM 950 training many times. I have traveled to many customer locations. We have conducted the trainings here for customers who have come to BNC for the testing. So we know the presentation is worthwhile. This will be a little different because now that current climate, a lot less travel, we would still like to be going out and showing these to users. But this is our first chance of trying to show this online. And so, let's see, there's only so much time really that we can ask for your attention watching a webinar. So we are going to try to keep the information that we cover today on a very, very basic level. Some of the questions that you may have could be dealing with something more complex than what will be covered today. If there is time, if it seems that such a question can be answered easily, then we will address those. But let's try to keep the focus today really on some basic operation, how to get the SAM up and running, and how to measure, and probably most important or equally important is the using RadResponder or using Reachback capabilities. This seems to be paramount to a great many of our customers, particularly those in the hazard response, emergency response. Let's see. What we want to cover today is learn. So we will learn techniques, again, very basic. We want to avoid common mistakes. We'll, as I think of mistakes or questions I've had in the past, we'll try and cover those. We want to achieve reliable and effective results. This is data collection, and data provides the fuel for statistics. And what the SAM does is statistically try to identify with the confidence what isotopes you may be measuring at the time. We want you to achieve reliable and effective results. So again, this is all about how to collect the data, the best way to do it. We hope that what you learn here will help you train others. And your questions will help us learn what's important to you. One of the disadvantages of doing this online is I don't have the opportunity to see people raising their hand and stopping to ask questions. I also don't have the advantage of being able to see people's eyes start to droop when I'm going on and on a little too long. So we'll try and keep the focus and keep things punchy as best as we can. Go ahead, Cody, and let's move on to the next slide. The star of the show, this is what we're going to talk about today. This is, I can promise you, for those of you who have been watching the inauguration ceremonies this morning, this will be a lot less well presented. Okay, the SAM 950 isotope identifier, the SAM 950 uses state-of-the-art technology, the algorithms that we use for identification. We do use a PDA/smartphone inside the device, and so there's easy control with a touch screen. You can also use push buttons. And after a while, with a little practice, I think you'll start to build up your own confidence level in operating the SAM 950. Let's go ahead and move on again here. One of the things I want to mention is today I may be using some interchangeable terms, smartphone and PDA. Well, it's basically the same thing, but essentially that's what the screen, interface screen of the SAM is. It is a PDA. The only thing that keeps it from being a smartphone is there's no SIM chip inside of it. Another interchangeable term that I tend to use is nuclide or isotope. They are basically the same thing. They are a variant of a particular element in a radioactive form, in one of its radioactive permutations. And then the SAM 950 and Peekabout. There will be times when I'm kind of using those interchangeably. Peekabout is the operating system. Peekabout is the program that allows the SAM 950 to do all of its stuff. It's essentially what you are interfacing with. Sometimes I refer to the SAM 950 and the Peekabout really is the same thing. I want to get this out of the way so that if there is any confusion, maybe you'll understand why. It's because I'm confused. All right. The items in the SAM, if you've opened up your case, you've already seen that the star of the show is the detector unit. It is hand graspable. It's like a very large camping flashlight. So you do grip the handle, you do face the round window forward. That is what we call the window. That is the window of the detector. It's very much like the iris of the pupil of your eye. And this is what collects gamma photon data in the same way that your eye gathers visible light photon data. What else we have here? We have an AC to DC power adapter for the SAM 950. Plug the cord into the wall, plug the other end of the cord into the brick, and plug the round 4-pin connector into the rear of your SAM 950. We have some images for that later on also. There's a vehicle charging adapter, and this is a nice feature, a step up from what we used to do with the SAM 940. It had a vehicle adapter, but you could only operate the SAM with the vehicle adapter. With the SAM 950, the vehicle adapter is also capable of actually charging the SAM battery. So it's a little step up there. We have two shoulder straps, actually, if you look inside the case. One is for attaching to the SAM 950. I do have one here. There we have a little cleat here in the front near the top and another one here in the back. So you can attach a strap, hang it over your shoulder, maybe take a little bit of weight off of your hand if you're going to be using this for any extended period. And of course, it comes in a waterproof and shockproof carrying case, and that case also has a shoulder strap that you can use if your hands are full. And I know I've seen a lot of hazard response teams walk in with just weighed down, full battle rattle and all their equipment. So the strap is there maybe to help as well. Let's go ahead, and I kind of forget what the next screen is. Oh, just some specifications about the SAM. It has a 4 gigabyte storage capacity. So not only does it store the spectra that you capture, you can also capture photos. You can record video. You can record audio. You can enter text versions of your comments for notes on a particular measurement that you've taken, and all of that information gets saved with that measurement file. And with the 4 gig capacity, we're talking well over 10,000, but 10,000 files, events, including all of any photos and videos and so forth. So it will take that many, but maybe from time to time it would be good to go ahead and empty the database out onto a PC and free up space on the SAM 950. Let it operate at peak capability. The SAM 950 has a Geiger-Muller tube, and we do use that to extend the dose rate from very low to very high. This was a request that if any of you ever used the SAM 940, you recall that the SAM 940 gamma dose rate range went from about 10 or about 1 microrem to about 10, or say, I used to have this stuff at my fingertips, but it used to go to about 10 millirem per hour, because once you got to that kind of rate, you're probably also at a count rate of somewhere near 100,000 counts per second, which is very difficult, even for the SAM 950. If you're up at a rate of 10 millirem per hour, or if you're up at around 100,000 counts per second, the data collection, the data processing is not so reliable. It starts to kind of drop off, actually, and it becomes less, frankly, it's not even an identifier anymore. It's just a very large dosimeter. And we did add the Geiger-Müller tube because, by request, people were asking for the ability to continue to use it, to continue to measure dose rate in certain circumstances beyond what normally would be allowed by the microprocessor portion of the SAM. So we do have that there, although at 10 millirem per hour, I may also want to mention that that's usually the safety range that most people recommend, is allowing to expose yourself for any kind of extended period. The IAEA, International Atomic Energy Association, their safety standard is 10 millirem per hour. It's, I think, also about 100 microsieverts per hour. And that's when they say, hey, you don't spend too much time at this level. And in fact, when you get to this level, you may think about backing off and dropping that dose rate. So really, we hope you don't have to use the Geiger-Müller feature. We hope you don't find yourself in that type of a situation. Neutron, the feature, we do have neutron capability. It's an option if you've ordered it with your SAM 950. It is available in two forms. The video showed that it was a solid state lithium based on a substrate, a lithium substrate. We call it Domino, and it is a solid state detector. You can, if you wish, this can be made available with the tried and true traditional neutron detection of the helium-3 tube, a gas-filled tube mounted near the front, just above that flashlight window at the front of the SAM 950. Operating conditions, minus 20 to plus 50. Let's see, that essentially is about minus 4 degrees Fahrenheit to 122 degrees Fahrenheit. I probably should have put that on the slide. It's ANSI compliant. That's the American National Standards Institute. They incorporated ANSI 42, which is a set of rules and compliance regulations for handheld radioisotope identifying equipment, radioisotope identifier, RIID, RIID. You may also hear us refer to the detector as a RIID, but that's essentially what the SAM 950 is. Let's go ahead and see what we have here. If you go to the rear of the unit, you will learn that what you have in the back is a USB connector. This is useful when you are offloading spectrum information from the SAM 950 onto the PC-based Peak ID analysis software. To the right of that, you'll find the charging connector. It fits nicely with the connector. Oops.
Made it angry. Don't worry about me. You'll go on.
That's right. So the battery charging is in that connector. Below that is the power switch. A couple of things I think I would like to cover regarding charging and battery usage. Keep in mind that when you are charging the SAM 950, when you have that brick plugged in, the cord from the brick plugged into the back of the SAM 950, you're charging the SAM 950's lithium-ion battery. When fully charged, you can expect about 8 hours of operation, continuous operation of the SAM 950. What's important to understand is that the smartphone itself also has a lithium-ion battery. And the lithium-ion battery, the rechargeable lithium-ion battery, gets its charge from the SAM 950's lithium-ion battery. So the PDA, the smartphone, is getting its charge from the SAM gets its charge from either the vehicle adapter or from the AC-DC adapter. You don't want to let the PDA battery get below 5%. Just like you would on your phone, there comes a point when it won't even power up because you've let the battery get so low. So from time to time, swipe down from the top like you would ordinarily on any phone and check the status of your battery. For the most part, if you keep your SAM charged fully, then the battery of the phone will usually always be charged fully. The SAM battery charges from the AC and the DC adapter. Basically, the rule of thumb would be if you're going to charge the SAM 950, charge the SAM 950 with the power turned on. The PDA only can charge its battery when the SAM 950 is powered up and turned on. So I would recommend, as a matter of maintenance, that the SAM 950 be charged at least once every month. During that charging period, turn the SAM 950 on to ensure that the PDA and the smartphone is topping off its battery as well. And just kind of make a note that that's my recommendation for best practices. You shouldn't have a problem ever with power by following those kinds of guidelines. I think that pretty much does that. So again, in the back, the charging, the USB connector, and the power switch. Let's see, what's with the next slide, if you would please. And the SAM 950. Okay, well, there are three important things that I want you to get today to operate the SAM correctly. These three things are to turn it on, kind of obvious, perform the auto calibration, and perform a background. These three things, 1, 2, 3. We're going to cover number 1 right now, and that's turn the SAM on. If you have a SAM with you, please feel free to come along as we do through the steps as they are described. Turn on the SAM 950. The power switch on the back, little ring around it, will light up red. That lets you know that the device is turned on. On your screen, the loading screen message will eventually show. From a dead start, I think first you'll often see the Samsung insignia that you'll often see on and Android information that you'll see on most smartphones. After that, you'll go to the loading. It takes about 40 seconds. We include that message so that you haven't done anything wrong. Expect about 40 seconds worth of loading. When the loading is complete, the SAM will immediately begin auto calibration. Okay, this is the first thing that it does, and we want you to complete it. So that's items 1 and 2. Item 1, turn on the SAM. Item 2, there's still more to say about the auto calibration. Do not have any radiation sources near the SAM when you are performing any of the calibrations, particularly auto calibration. The SAM 950 uses a small amount of potassium 40 that we have inserted inside the SAM 950. It's a small granulated salt is what it is, potassium chloride. It's a salt substitute that you can buy at the grocery stores or the nutrition stores. And as in any amount or population of potassium, there will always be an amount of potassium 40, an isotope variant of the basic potassium atom. There's usually enough in just a small amount that there will be enough of a peak for the SAM to look at that and say, 1,461 keV is for the potassium 40 or the K40. So that peak that I see must be the potassium peak, and I'm going to adjust my graph so that the point of 14 keV or 1400 keV or 1460 keV rather is on that peak. We don't want other isotopes that are in the area to accidentally provide some larger peak, would cause and cause the potassium peak to disappear into the background. We don't want the SAM to look at a very large peak and say, "Oh, that must be the potassium peak," and put that position, that 1461 keV, at the wrong position on the wrong peak. So, long-winded way maybe of going about it, but just best practices. If you have check sources, if you are near a room where you keep sources, if you have arrived at a scene where you think there may already be radioactivity present, take the SAM away as best as you can, get it into a place with very low radiation, normal operating conditions, and then let auto calibration perform. This happens automatically at power up. Just general rule: when you power up, no sources nearby. I did want to talk on a topic that I will sometimes refer to as KEV. That's an energy. It is an atomic energy term, and various isotopes will have certain energy amounts to them, and these gamma photons of these isotopes are referred to in a unit of keV. That's 1,000 electron volts. So it's an atomic measure of relative energies of the gamma range. The SAM 950 operates essentially from the farthest low point at about 20 keV all the way up to the farthest right of the spectrum, and we'll see that in a little while, where that's usually around 3,000 keV, kilo electron volts. I may also refer to that as 3 MeV. When we get up into the higher ranges, we maybe change the K to an M. But I just want to mention that if you hear me using those terms, I'm talking about a specific energy value that tends to be characteristic of the isotope that we're talking about. Let's see. So after the auto calibrate, let's see. So I am pretty much covered. We're doing potassium 40, so make sure that we have a clear view. The SAM has a clear view of that. And let's go ahead and move on to the next slide. When auto calibration is complete, you'll go into the main screen, and that's what we're looking at right now. This is ordinarily when the SAM has been turned on, when auto calibration is complete, your main screen. It's a quick check for you to check the current condition of the SAM 950. Along the top bar, status information regarding what library, which isotope library is currently being used, what sort of threshold alarm am I using, what's the battery status in terms of percent. In the center of the screen, the main portion of the screen, we call it the gauge screen. There's like the tachometer there, a logarithmic based gauge. In the center of that, the largest set of numbers is the dose rate, and this will constantly be fluctuating, probably on the average of every second, because that's how quickly, that's how regularly we update the monitoring. Every second, you may see that change, and you'll see that it fluctuates because that is the nature of radioactive energy. It's not just this constant beam that's always being shot out like a laser. Radioactivity is always in flux or fluctuation. So you'll see that move around. Just below the dose rate, you'll see another set of numbers that sometimes I consider really a more important set of numbers, and that's the counts per second. That's the number of gamma photons that we're receiving per second. The gamma photons are the result of radioactive decay, Every time we have a step of decay in a radioisotope, then it emits a photon at the gamma energy range, and that's how we can tell that there is radioactivity. That's how we can tell counts per second. If you have the neutron capability enabled, you'll see just to the left neutron counts. If you have any neutron counts in the area, that should activate. Neutron counts, sometimes you can see a small number of 0.03 or 0.1 or 0.01. Let's see, I'm looking at that, 0.1. If you ever something like that, that might just be a cosmic ray. The neutrons do fall out of the sky. They are generated by the sun. And so sometimes they'll pass through the helium tube, or they'll pass through the domino solid state plate and get that. That's not to be too excited about. If it gets to around 1 count per second and it's steadily at 1 count per second, that's when you start to be concerned. You're probably near a neutron source, which means you're probably near a special nuclear material. Again, special nuclear materials will tend to be almost like cooking and boiling in themselves, and some of them will generate neutrons. The rangefinder on the right, when the rangefinder will appear if it kind of gets a sniff that, hey, I think there's some counts that we should look at. The rangefinder will tell you to move forward so it can get a better look, get a better idea of the count and the amount of activity that it's recognizing. It will eventually tell you you're in range. We'll go more detail about this, and it'll also maybe tell you to kind of come back. It's not saying run away. It's telling you to just come back a little bit. We want to get into the right amount of counts per second that gives the best statistical result from the data that you're capturing. I am rambling quite a bit. I told Cody that I'm going to join a 12-step program for compulsive talkers. You've probably heard of it. It's called On and On and On. And again, if I could see the audience out there, I'd be able to tell from the drooping heads, slack jaws, and so forth, whether this information is coming in clearly, too fast, not clearly. We will try to keep track of questions as they come in, but again, these do help keep us focused. Let's see. Besides the main screen, we have the ability to control the goings on of the main screen. I think that's the next slide. And of course, using touch screen, I told you that you can, well, I didn't cover that very much, but the very bottom of the touch screen, very bottom of that main screen is some soft keys. And when you touch the key below the soft, or when you touch the soft key, it will take you to that function. Without touch screen, maybe you work in a environment when you have to deploy, you are going to be wearing gloves. Gloves do not work particularly well with touch screens. And so fortunately, we have made a set of switches on the handle that are easily accessible from your thumb. And with these switches, you're able to do all of the things that you can normally navigate using the touch screen as well. Left and right arrow obviously can move a cursor left or right. Forward or backward would be maybe up and down a menu, or from one section of a screen to another section. Enter, the enter button in the dead center, pretty much tell you to do that thing that I've just highlighted with the cursor. The go back and menu button, this two things. First off, it will go back, like on your phone. There's usually the go back to what I was doing before, go back to that screen. But it also, if you press and hold it, it will also pop up a settings menu on the main screen. We'll discuss that there'll be opportunities for you to maybe use that from time to time. And really kind of the special stuff is that forward button. If you press and hold that for a long time, the flashlight will turn on at the front of the SAM 950 if you are operating in at night or in a dark environment, a warehouse perhaps, or smoke area. The flashlight can be helpful. It's a feature we put in. People have said it's very handy, but that's how you operate it. Press and hold it to turn it on, press and hold it to turn it off. And that's pretty much all we really need to talk about of the controls there. But yeah, go ahead, Cody. Let's go ahead and move on. Measuring background. Okay. This is step number 3. I mentioned that we're going to push very hard for 3 basics. We've covered 1, which is turn on the device. We've covered number 2, which is auto calibration. Let auto calibration complete. Otherwise, our information is not to be trusted. We need to calibrate on a known energy. Third thing is perform a background reference. Okay. Just want to mention then, first off, one question would one thing to mention is what is background? Essentially, background is what is surrounding all of us every day in whatever circumstance you're in. We are always exposed to some measure of radioactivity. That's just a normal daily thing. There is carbon-60 and carbon. I can't remember what for the carbon dating. There's isotopes in water, deuterium and tritium, and potassium-40, which is in nearly every vegetable or fruit, most anything that comes out of the soil or the dirt. And this is just a normal part of life. We want to, however, take a look at the amount of energy in our normal area, because we want to take a photo, we want to remember that and say, all right, this is what we can expect to be the amount of radiation here in the background, what we expect in the background, so that we can remember that and compare what we're seeing from now on to that background. And if we start seeing counts and activity that's consistently above the background, we may cause an alarm. We may throw on the rangefinder that says, hey, we think we have something. Take a look at that. The SAM 950 will try to get your attention to say, hey, I think we have found something that's higher than background and worth investigating. So this is why we perform background, is to take a picture, and from that point on, I mentioned every second we're updating. We're also subtracting the background every second. So we take a look what's out in the radiation in the area. We subtract what we remember from the background reference, and then we look at what's left, and that tells us if we've got a problem. If it's significant and it's caused quite an activity at a particular energy, we'll even start to know what isotope that we've detected based on a few counts above background at a particular energy line. Let's maybe have a look. If you have a background, I think, well, let's make sure that okay. Maybe it would be helpful, let's go back for a moment, that you know how to start the background. You're on the main screen. Auto calibration is complete. We've talked about the go back menu button. If you press and hold on the go back icon in the lower right hand corner of your screen, you should see a setup menu or a menu, a choice pop up. From this menu, you can either go to look at event logs, which these are spectra, or these are measurements that you've performed in the past and are stored in the SAM, or you can go to the setup menu, or you could exit, but there's other ways to exit out of SAM 950. But the event log and the setup menus are two very important things. We won't be able to go into too much detail on those, but it is important to know how to get to the setup menu. So if you have the device with you, and in a little bit we're going to do, I think, try to do a live demonstration of how background is done. Pull up the menu, select setup either by touch or move the cursor there and press the enter button on the thumb switches. Scroll down, you'll find a section called background. When you highlight it or press enter, I put mine on do not disturb already. Press the button, up or down button to scroll, press background, and watch the magic happen. We'll show it to you in a minute. Again, very important, just like auto calibration, move any sources away or move the SAM away from any sources. We would like to take a look at what the normal background is in the area before we go searching or measuring. So let's always make sure there's no sources around. And let's go to the next screen. It'll show you what you should expect to see. Is that, or is that yours? Or
That's me.
Oh, it is yours.
Don't worry about it, Mark. Keep going.
Okay. Do not disturb button. Background measures in 60 seconds by default. You can adjust this, but most people don't need to. 60 seconds is usually good enough. You will see a spectrum begin to grow. And as this spectrum grows, what is this spectrum? This spectrum is the photons that I've been telling you about, from 20 keV to 3000 keV. And you'll start to see this growing, this grass and this humps and bumps growing. This is the radiation that's surrounding you in wherever you happen to be right now. One of the things you'll notice is most of that energy tends to be in that section of the screen to the left where is low energy. And this is why the human animal is still able to exist on the planet, on the surface of this planet. The normal radioactivity around us is in the low range. Therefore, we can absorb it and deal with it, and we get along fine in our daily lives. So have a look at the screen. What you'll see is it'll tell you the date, time, acquisition, things like that. The grids, the vertical grid, the horizontal grid. The vertical grid is the number of counts, and this is the counts. Underneath that entire thing is your total counts of photons. Each photon that we collect is considered a count. And along the horizontal axis is that energy from 20 keV to 3 MeV. So we have the number of counts, we have the 20 keV to 3 MeV, and each one of those channels, which is, we were separating that out into 1,024 channels. You see the count for the particular energy that is located at that particular channel. And this is what we see when we perform a spectrum. This is what you'll see when you perform your background. And you will probably notice a hump around the middle of the screen. This image also shows that little hump. That is the hump that is produced by the potassium-40. We now know the location of that hump is at 1,461 keV. And that is what we're calibrating on when we perform auto calibration. And this is always there. When we look at it and measure the background, we see that too. And we know that there's always going to be that much potassium energy in the area. That also gets subtracted from anything we measure above and beyond the normal background. So that's the reason why we do background. That's how we do background. That's the number 3 important factor to learn how to do. Turn it on, auto calibrate, perform a background, and that gets you ready to use the SAM 950. Those are the important steps. Were we going to do a background demonstration?
We are, Mark. So, yeah.
Cody's going to show you the screen of the SAM 950. and performing. Well, what's going on? Jump right in. And
Okay. Yes, but anyway, so to expand on what Mark's saying, you might have heard it go off earlier. The SAM 950 is a live unit. So what I am going to do now is switch over to a streaming view of the UI display. It does require me to do a bit of finagling over here. So I'm going to just, and then hopefully switch right over here. Perfect. So just like Mark described, all you have to do is hold the back button located on the right side of the device. Click Setup. And now if you scroll down, background will be visible from the opening of the menu. All you need to do here is click it and it will begin. So now we have about 60 seconds of airtime. Is there anything you wanted to commentate here, Mark?
Yeah, I could continue to yammer all day given the opportunity. But as you see, let's see, because we're doing some streaming here, you'll see some breakup. Ordinarily, what you'll be watching on your own screen should be a little different of regular 1 second, 1 second, 1 second, 1 second, 1 second. These tend to pile up a little bit here because of the streaming. But what we're seeing in real time is the background of that's in Cody's office. In fact, Cody, if you want to, can you touch your finger on the bottom horizontal axis below that hump in the middle of the spectrum? I don't know if I showed you how to do that yet.
Right here?
Yeah.
There we go.
Okay, and then you move it so it's kind of right dead center in that hump there, wherever you can.
Okay.
And up there it says 1458. Well, that's pretty darn close to that 1461 I'm telling you about. With KEV, that's the potassium 40. What this tells me, being such a almost dead-on number like that, is that auto-calibration was successful. Our energy calibration is reliable. This is maybe a good test if you wish to check to see if your calibration. You can check it during a background and touch the horizontal screen at the bottom that shows you the energy. The cursor will pop up and move it to the middle of that hump or the peak, the energy peak, and it should be close to 1461. And if it is, that confirms that you did your auto calibration correctly and your background is now complete and you are ready and raring to go.
Yep. And there's that all done. So I'm going to go ahead and bring myself back here. And we'll get right back into the presentation.
Yes. Yes, I think that would be so those are the basics to get you up and running. It might also be a good time now to discuss turning off the SAM. We've given you enough rope to make yourself dangerous. There is a way to turn off the SAM to make sure that, again, the battery in the SAM doesn't get used up, or the battery in the smartphone gets used up. So if you take a moment here, go ahead, please. The red switch at the back, the power switch in the rear, press it, should pop out, the light should turn off. Look at the screen. I think briefly it'll take you to sort of an internet setup screen, but eventually you should see a message asking you whether you want to turn off the HD screen, the high def, basically the visual screen you're looking at. Really, the best practice is always turn the smartphone off. We will turn that smartphone off when we turn off the SAM. And so press yes. When you press yes, the SAM will finish turning off, the screen will go dark, the SAM is turned off, you've done your job. You can put it away. You know that there isn't things running inside. We're not actually or accidentally burning up any energy from the batteries. And you could put that away and store it for a month, and in a month's time, take it out again for normal maintenance, power it up, charge it, make sure you turn it on when you're charging it, charge the PDA, the smartphone as well. And that's pretty much the life and death cycle the turn on, turn off cycle for the SAM 950, and that's kind of like the first portion of our training. And some of the best practices. As often as I can, I'll try to remember to tell you, hey, here's really the best way, and here's a tip to how to do this. All right, I think I've talked enough. Let's take a little break. So I can take a breath, and Cody can use this time, if you would, please.
Yeah, of course. So thank you, everybody, for getting through that first portion. As Mark just described, that is the core functionality of the SAM 950 unit. You power it on, you auto-calibrate, and then you check for background radiation, and you make sure that is stripped out of your final result. Right now on the screen, while we get our bearings a bit, are a couple of quiz questions. Once you answer one, you can continue on to the second one by clicking the next button at the bottom of the display. And then after we look at these poll questions a bit, which are just a couple of fun questions to gauge your experience with radiation, we'll go ahead and answer a few questions and then move right on to the next segment of this virtual training. So just one moment.
Let's see what else we've got going here. Make sure I'm caught up with my notes. I'm kind of checking my own memory here to see if there are items I should have mentioned.
Oh, looks like we... All right, so it looks like in terms of the polling, a lot of people here have experience with isotope identification equipment, which does make sense. We did create this virtual training with the appeal for both people who are new to this equipment, new to the SAM 950, but it's also for experienced users or those who are looking for a refresher. So I am glad to see that a couple of people are not quite in it yet or are going to be in it very soon. As for the first question, the answer, according to all available sources of information, is no. Phones emit a low amount of non-ionizing radiation. If you consider that a trick question, I apologize, but it is just for fun. I see a lot of people changing their answer. Don't worry, this isn't a high school course. You're not going to get graded on that one, but if you want to change it, you can go ahead and do that. But speaking of questions, let's go ahead and get into some of these questions here that have not been answered yet.
I've not been following it, so if you want to go ahead and if you've been collecting them, go ahead and shoot a few. Maybe we have a few minutes.
It looks like actually one of our associates, Alan Gonzalez, has been answering a lot of the questions in chat currently. So it looks like we have everything covered for now. So I think we'll wait here another moment just in case there's a question directly leveled at Mark. One question I actually want to ask you, Mark, that came up when we were discussing the presentation was about what you should do when you're trying to power up the SAM 950 in a location that is already filled with a radioactive element.
Okay, this is fair. So I do get asked this from time to time, particularly from first responders, firemen, people that may get called out. Maybe something has happened, some set of conditions or circumstances, and the emergency response team is called out. If there's any reason to think that maybe there might be radioactivity involved in these areas, the radioactivity, if present, can sometimes form sort of a bubble, a dome. The wind can turn it into a plume and move it downwind. So the question is, if we think it's there, is it fair for us to pull out our SAM, try to do auto calibration, and try to do background when in fact we may be surrounded by radioactivity? And God knows, I hope that never happens to you. If you think that you are going to a site, an event that may have this dome of radioactivity already present, I recommend that you turn the SAM on your way there. Turn it on before you get to your final location. Allow the SAM to turn on, do the loading, do the warm-up. let it perform auto calibration, and let it even perform a background. If you forgot to do that, if you forgot to do any of that, and you're just pulling the SAM out of the case when you're already on scene, remember that when auto calibration starts, there's a small area in the screen that says cancel. Well, by all means, if there's any doubt that there might be stuff in the air that would fool the potassium or fool it into thinking something else was the calibration peak, press cancel. It's not ideal, but it's better than calibrating on a bad source or a wrong and incorrect energy. And, really that peak is probably going to be where it was the last time you used it. It may have cooled down a little bit. As long as there's no major temperature extremes, the energy calibration is probably valid. Also, if you think that you're going to be in one of these situations, don't run the background. If you think that the background is going to be elevated, and by being very high, you won't really be able to find things because it's already there, it's already everywhere. Don't run the background. Use the background from whatever last time you used it in an exercise, at your office, at your lab, some known benign area. Save that or use that. Don't run it. Is that kind of answering the questions that you're posing, Cody?
Hey, I mean, yeah. I will not enroll you in that 12-step program. It is just when you go on and on, I learn more and more. So,
well, thank you.
Yes, and then just real quick, I do have one question, and then we will try to get into the next part of the presentation. Osama is asking, what is the lowest energy that you can measure with a SAM 950?
Depends. Oh, energy. Well, it depends on what you mean by energy. If you mean, for instance, what's the lowest dose rate? Again, the needle will start to pick or probably drop off at about 1 nanorem per hour. If you're talking about a isotope energy, talking about that entire gamma range from around 20 keV to around 3 MeV, or even beyond it, or even down into sort of the X-ray region, which is a little below. That 20 keV actually is sort of straddling a border between some X-rays and some gammas. The two energies do intersperse over that area. The gammas, where am I going? Okay, so 20 keV is the lowest energy. We don't recommend using the SAM 950 as a X-ray detector, or for that kind of application. There are other products more that are better suited for that. If you're talking about what's the minimum activity that it can detect, meaning how small of an activity of something on the case of Curies or Becquerels, I'm thinking it's just like a few hundred Becquerels is the minimum detectable amount, MDA, minimum detectable amount, for a 3x3. That's a 3-inch by 3-inch detector. The SAM uses a 2-inch by 2-inch sodium iodide detector. Standard, you can also get it with a cerium bromide or a lanthanum bromide detector, but the standard is the 2x2. And so, we're talking maybe, and again, I don't want to blow smoke, but it's going to be, in the low hundreds or maybe hundreds, maybe around 1,000 becquerel as the smallest minimum detectable. I could be wrong. I'd have to go back and check a number of papers that I have, but I'm at a point in my life where I try not to bother memorizing things that I can look up. So call me lazy. A lot of people do. Osama, I hope that you know, as far as whatever you meant by energy, that answer covered that for you.
Excellent. Very in-depth answer and very exciting. Hopefully by the end of this presentation, everybody will be able to hit yes on that isotope identification equipment. If not physically, then virtually. And speaking of getting experience with the equipment, we're now going to move into the second part of the presentation, which will involve event reporting as well as manual ID. So let's go ahead and transition right back into that. And
thank you very much, Cody. So again, I want to reiterate that we've given you just enough rope to be dangerous. And so if you did turn off your SAM at the end of that first session, then it's time to turn the SAM back on again. Pardon me. But this is an excellent time to go through the 3 basic steps again. Turn on the SAM, and it will take about, again, 40 seconds for it to load the Peekabout software. At the end of the 40 seconds, the auto calibration will begin. Auto calibration, for the most part, is going to take less than 30 seconds. And then once you have that, you can perform, go to the event or setup log and select background and perform a background reference. Get used to doing these. These are the proper steps. Don't cut corners. Use the device the way it was intended to be used. And this also gives you an opportunity, maybe if you want to try and play with the cursor on the horizontal axis, touching that and clicking or touching and dragging with your finger. You can double check whether your calibration has been successful by taking a rough look at the position, what energy is at the center of that potassium-40 peak. Otherwise, the process of powering up the SAM and auto calibration and performing the background is similar to putting gas in your car, where it's something you have to do, and maybe you have some free time to think about what you forgot on your grocery list or other things that may cross your mind while you're doing, pumping gas or watching paint dry, grass grow. Other exciting ways to pass the day. Some of you may still be going through the process. I'm going to start looking over here on the slides and discuss radiation monitoring. Once you've done all those steps, we're ready to go out and look. We're ready to go out and measure. Some people will know where they're going to go. They know where the source is. That's a luxury, folks. Some people have to turn on the SAM. These are especially the hazardous response folks. They have to use the SAM to try and find where the radioactive sources are. Let's see, what do we got here? Again, top row is sort of a status. You can check the phone status by touching at the very top and swiping down, and it should pull up the phone status bar, so you can check the phone's battery status, date, time, all the things you would expect to see on your phone status bar. The center of the screen, the gauge. Again, rangefinder will be our friend as we're searching. Along the bottom, our soft keys. You'll see 3 choices there in this slide. Sequential mode is very specialized application. On most SAM 950s, by default, it's deactivated. You can use it. You can go to the menus, the menu section that we have discussed, and use that, but it's very specialized for certain types of applications and used maybe only 1 or 2 or 3% of applications for the SAM 950. What you'll typically see is real-time and manual ID, and both of these soft keys are there by default. the real-time soft key is active. It is the visible current screen that you see. Manual ID we'll cover in just a moment. Let's see. The SAM also discussed something called stabilization. We've talked about auto-calibration, and I mentioned to you that auto-calibration uses a potassium-40 energy source and looks for that 1461 keV energy peak to calibrate itself. Well, that's nice, but you ask, what happens while I'm using it? What happens? I mean, do I ever need to go back? Do I have to keep going back and auto-calibrate from time to time to make sure things are legit? And no, you don't. The SAM 950 is always behind the scenes running what's called auto-stabilization. Auto-stabilization, very much the same function as auto-calibration. When you are not recording an event, for the most part, always behind the scenes, the SAM's taking measurements of the background and taking measurements of the area where you are. And if it sees that peak has started to drift off of that 1461 keV, the SAM knows that it needs to electrically inside add a little gain or subtract a little gain as necessary to put the center of that peak back onto the 1461 energy line. So this is happening all the time. Every so often you may see in the top of the screen, I don't have mine turned on, Cody, as you're saying, every so often see some stabilization in progress. If you ever see that, that's what's going on. And the SAM is doing this and letting you know that it's doing this. Let it do this. It's helping you keep your SAM calibrated and stabilized. So the other thing that I'd wanted to mention is up at the top there, the alarm threshold system that you may be using. You can use two. One's called fixed, which you see at the top of that screen. Another is called variable. And these are ways in which the SAM decides to, what sets a threshold to turn on the alarm, to get your attention. Again, the alarm is not always something you should be alarmed. The alarm is really to get your attention, and you can set it to trigger at any point. If one of those energy channels gets above 1,000 counts per second, then the device will alarm. And that's on the fixed variable. By default, you can set that higher, you can set that lower. If you find that having it at 1,000 counts per second is a nuisance and causing you to alarm over things that, I know it's a little higher background here, but still I don't need you to alarm all the time. You can go into the settings menus and adjust that threshold. Variable is a little different. Not everybody uses it. And again, probably more for specialized. If you're in a situation where you're going to be mostly surveying a large area like a field, and you're making measurements of the total activity across this field, and you want to do identifications on this field, the background may change. The background radiation may adjust at different portions of this field. So the SAM looks at the previous 20 seconds and checks to see if there's been an increase or gradual increase in background. And then we'll make an adjustment to say, okay, maybe we'll goose up the background threshold here a little bit, because we don't want to start any nuisance alarms. We know we're going to be operating in a fluctuating background, so I'm going to use the variable mode to avoid doing the nuisance alarms. If this is true, that you're using variable, then when you've completed background, when you're powered up, before you start going in search, give the SAM about 20 seconds of just kind of sitting quietly at one place so it can store a record of backgrounds a record of background samples, 20 seconds worth of background samples before going out and hitting the streets. Let's see. Mode allows autocorrect. Yeah, I think we've pretty much covered that. If there's any other notes, AutoCal, auto stabilization. This is also helpful. If you are on a project where, and I've seen this happen mostly in situations where people are taking the SAM into a mine and they're looking for uranite, they're looking for pitch blende, they're looking for ores that may contain certain isotopes. This can raise the background. This can also expose the SAM 950 to peaks, high activity peaks, lots of counts, besides the potassium. And with all this, I'll call it noise, the SAM can lose track of where that potassium peak is. So it's always a good practice. Put that down in your notes, Mark says. Every so often, take the SAM out away from a particularly active area, give it a chance to perform some auto stabilization, give it a chance to see the potassium peak, give it a fighting chance. So it would be a good thing to do every so often if you're going to be operating in places where you know there will be some very active isotope activity. Now, by this time, I'm sure everybody's on their main screen. We've told you how certain alarm thresholds can be activated. And I mentioned that some people don't have the luxury of knowing exactly where they're going to be going to find where a source of radioactivity is. And so we perform a surveillance. That's what SAM, by the way, stands for Survey and Measure, or Surveillance and Measurement. That's how we came up with that. Let's go ahead and I want to talk about finding. You can use the screen, the gauge screen. You're watching the fluctuation of the dose rate. You're watching the fluctuation of the counts per second. If you see the counts per second kind of rise up, to, and maybe even turn yellow or just kind of go for a minute and then go back down, well, hey, maybe I'll go back and look at that. If you're in a circumstance where you're watching your footing, you're avoiding puddles, you're avoiding debris on the ground, you may look away during a time that the fluctuation occurred, that the counts per second rose up. For this, we have another type of surveillance screen. We call it the Finder screen. It's available to everybody. It's right there, and it's easy to get. You just have to touch your screen and swipe left, swipe right, move the up, down buttons back, forth. Lots of ways to go back and forth from the screens. Both screens are valid for performing search. Both screens will allow you to pull up the setup menu. Both screens will allow the same performance of alarm thresholds and so forth. But the Finder is a different feature in that in case you had to look away for a moment and you look back at your screen, it's showing you a histogram, what's called a histogram, which is a timed record, and of your previous 20 seconds. It takes 20 seconds to go completely across that screen. And if you look down there, maybe you missed that glitch on the counts per second, and you look back on the screen. If you're using Finder mode, oh, hey, look, there's a peak there. Looks like I passed something. Well, go back to where you were a few seconds ago. Go back and then focus in on those areas. Start and see if you can get that orange line to rise up at a continuous high count, and see if you can zoom in on the source that you're looking for. Cody, are we going to be able to do a demonstration maybe to show how the Finder screen can work? many people have their preferences, which screen they like to operate with. Some people really believe in doing the finder screen. Some people would prefer to using the dose rate readings that are available on the main gauge screen. While I'm talking, by all means, Cody, if there's things that you need to do to pull up the live screen again.
Yep, I will go ahead and take care of that right now. Just got to
Please.
go ahead and get the setup working. So just one moment.
I do mention it because there are operators who really believe in the finder screen. They like having that second chance.
Hello, am I muted?
You're not muted, but your video turned off.
Oh, yes, that's required for the sharing of the UI. This is just an advanced warning. Anybody who's tabbed out right now, an alarm may go off on the SAM 950 that will play through my audio. It's a bit of a jump scare. So this is your chance right now to kind of prepare for it, because I am going to be passing a source right over the front of the detectors. So let's go ahead and...
There's no need to adjust your television set.
Your discretion advised.
That's right. This is occurring here. This is not occurring where you are.
All right, so welcome back to the screen. We're going to go ahead and exit out of here. Oh, you can see it's already getting...
Now, let's go ahead and make sure there's no sources in the area and let that get back to a fairly benign. I'd like to see, in a normal circumstance, I would say most places in the U.S., a normal background count for a 2x2 is going to be around 200 to 300 counts per second. Cody has some sources in his office, so it's never going to get quite that low. The detector can sniff out energies, within a few yards. But if you're walking along and you're using your gauge screen, and I'm going to ask Cody to just briefly pass, not too close, but just kind of pass the sources that he has, and we might see in a 1 second update rate that again, we're getting delays here because of we're using the streaming, but we may get a certain rise in the dose rate or certain rise in the count rate, and we may have missed it because we were looking away at the time. On the finder screen, go ahead and swipe across, Cody. The finder screen would tell us that, hey, about 5-6 seconds ago, or 20 seconds ago down here, oh, look at that. It goes nearly out to almost a minute worth of recording on the finder screen. It says, hey, we had some activity there. Maybe I should go back to where that activity, maybe I should reintroduce that activity. Cody, if you want to go ahead and do, and see if I can make that thing climb up again. And look at that. I came back to this area. Oh, yeah, looks like we've definitely got something going on. And let me go back and, I'm dropping off now. Okay, let me go zero in on where that source is. And maybe even get a little closer once I can identify where that is and step a little closer. Yeah, okay, I'm definitely getting some more activity here. I think I'm onto something. Whoop, past it. I better take a step back. But again, you can use the finder peak, the histogram on the finder screen, to zoom in or to focus in on the location while you're doing a search. Let's see. And I'm not sure that there's a lot else that we can look at while looking at the screen. Finder mode gives you that second chance. And again, a lot of people are big believers on that second chance. The alarm, which we did just briefly hear a moment ago. Go ahead, Cody, and let's let people hear the alarm.
Another pass through? All right, just a warning. I don't think my fish Donatello likes the alarm either, but here we go.
Oh, okay.
There we go. You might be able to hear that coming across on my microphone.
Okay, so you get the audio alarm, you get the peak there. If you swipe back to the gauge screen while you have the alarm going, and this time go ahead and leave leave the sources out in front of the window of the detector.
Here we go.
So if you hear the alarm, if you see the red screen, don't automatically think, oh my God, activity, there's radioactivity. I'm radioactive now. The SAM's just trying to get your attention. Okay. There's no point to get excited. It wants your attention, and this gives you the opportunity to focus in on what your job is, and that's to survey, to find, to measure. When you get to a certain level, for instance, like above 1,000 counts per second, the rangefinder on the far right there will tell you to move forward. Okay, now if you move your sources a little closer, maybe you start getting something. Cody, I don't know if you're able to do this along with in syncopation with my yammering, but when you get about close to that 2,000 rate, it says, hey, in range. In range. It's like, okay, well, then it must be around here somewhere. It means this would be a good time to make a measurement. If you get closer, and I don't think that your sources you have would get to that point, but if you start getting, say, above 10,000 counts per second, you'll see that in range insignia turn to an arrow pointing back over your shoulder and saying, move away. Again, it's not telling you you're in danger, although, again, the rule of thumb is always keep your exposure as low as reasonably allowable, ALARA, A-L-A-R-A. Okay, good. We got high enough there, got some counts up there, and says, okay, move back. Well, why move forward? Why move back? What's in range? And we're going to go to a spot now. If we can take a break and go back to the slides. Thank you again very much, Cody.
Yeah, of course. One moment. Let me deal with my tinnitus and getting us back into working shape here. One moment, guys.
Some people get the fun jobs, and some people get the easy jobs, and some people get the dirty jobs. And, we all take our turns wearing those hats. Let's see. Looks like Alan is just knocking them out of the park, handling questions and answers. Alan Gonzalez is the marketing and product specialist for the SAM series. Quite a few of the radiation and nuclear products. He knows what he's talking about. So Alan Gonzalez is also a great source. I also welcome questions from users, Cody, and we have a very talented technician, Jaswinder Singh, also a good source. So any of us will be happy to answer questions that you have on these products, particularly if you're out in the field and you're having an operation difficulty. So as I mentioned earlier, if the alarm goes off, don't be alarmed. I've had a number of people say, and then especially if this happens inside of a conference room, we're having a training and the alarm goes off, then people kind of get freaked out, like, what did you do to me? All it's telling you is you've gotten to a level of count rate that is statistically reliable. Data that you gather in this area or at this rate is going to be particularly reliable. Now, you may use the SAM to find a location. You may have to get right up to where it is, and the counts may be very, very high, but you've located where it is. Okay, that part's solved. Mark it with a piece of chalk. But if you're going to measure it, step back. If you've found the source, but thing still says move forward because you're still not getting, say, 2,000 counts, maybe 1,000 or 1,500 is about the only amount that's the highest amount of counts you can get. At least you've done your best. It still says move forward. When you get there too much, it's too much information, back off. You want to get as best as you can into that 2,000 to 3,000 counts per second. So I'd mentioned that on the gauge screen, there is the dose rate numbers, which is the larger of the two, and underneath it, the count rate. I like to rely on the counts per second as my determining factor for when I should do measurements. The sweet spot, as I refer to it, is between 2,000 and 3,000 counts per second. You found the source, terrific. Get as close as you can without exceeding the sweet spot. If you've gotten as close as you can and you're still not in the sweet spot, well, maybe you need to just take a longer sample to gather more data. If you've gotten as close as you can, you just need a longer exposure when you're measuring. So again, the helpful operating messages on the rangefinder, the count rate is less than what we would like for data, or the count rate is a little too high. You don't need to have it that high. What happens when the count rate is very, very high, this much energy, this much count and energy and dose can start to shove the position of the peaks, can shift them a little higher. The peak's there, but it starts to read an incorrect number. Not by a lot. It's not a major shift, but it can be enough in a critical situation. So, please follow the advice. Get to the sweet spot if you can. Don't go with high counts just because you can. Optimum, in range, 2,000 to 3,000 is what I recommend. If you do get into a range above the 10 millirem per second mark, or the 100 SeV micro sieverts, you will see the count rate, dose rate level is extremely high. Back off. That has an entirely different alarm sound. Weep, weep, weep. You heard it at the very beginning of that movie that we started off this presentation with. The screen kind of turns yellow tinge. You see the circular radiation indicator, and that's when you want to back off. You can adjust that. Your administrator can go into the menu and make it a little lower, because your administrator does not want people exposed to even that much. Or maybe people say, they can take it, they're tough, and may want to raise that threshold. But we use the IAEA standard, which is the, let me double check, I think it was the 10 millirem, but that's the default that we use. And make a note there, because again, that's for yourself, that's for your health. 10 millirem per hour, which if you're using sieverts is 100 microsieverts per hour. That's when you start to pay attention to the health of the operator. If you have to be there for as little time as possible. If you have the luxury of being able to kind of get out of that area, do it then. What else we got here? We've got the alarm. And this is also when you get up to something and maybe it's at like 10,000 counts and the alarm is really screaming. You don't have to back up very far to get that energy down from, say, 10,000 to 2,000. And this is something that's referred to as the inverse square law. This is another great thing that Isaac Newton shared with the world. And what it describes is the fact that the energy from a source, hold on just a second, please. The energy from a source decreases by the square of the distance. So what does this mean? Okay, you're at a source of, say, you're 1 inch away and you're reading, 10,000 counts with, certain dose rate or count rate. And well, if I move it back an inch, well, increased it by 2, but that doesn't mean that your energy has dropped off by 2. It means that your energy has dropped off by 10 to the second power. It's dropped off by 100. You've moved back just twice the distance. You've dropped it by 100. You move back, say, 3 inches. Okay, well, you haven't dropped it by 3. You've dropped it by 10 to the third power. You've dropped it off by 1,000. So it doesn't take very long for you to get back into a range where you can perform the counts per second or the measurements in the sweet spot. And again, same thing goes for your health. You know, when you get to a place where maybe the energy can be quite high, to get back to a safe level, you may not necessarily have to travel very far. And again, this is by virtue of the nature of how this energy works. This was defined by Newton. It's called the inverse square law. It can be your friend. So we get to the sweet spot, and we're at a point of 2,000 to 3,000. Well, we're in range. We want to make a measurement. There's 3 ways that you can do it. You can press with your thumb on the enter button for 2 seconds. Do a long press. By default, it will run and start doing a manual ID. Along the soft keys along the bottom, where you've got one that says real time, one that says manual ID, touch manual ID, and that will start the isotope identification. You can use the thumbs to use the left and right menus to move the cursor from real time to manual ID and press enter. But any one of these will start the measurement process. And then what you would expect to see during the measurement process is on the next slide. Let me make sure I haven't, this is how you start it. You start it with the thing that says manual ID. While the manual ID is operating, you will see that grass growing, the yellow grass growing. And if you see peaks, again, these will start to show up much differently than they did when you were running the background. If there are isotopes, specific isotopes, known isotopes, when I say known in the SAM's memory, it will compare the location of where that peak is and know that it's a certain isotope based on that energy peak or a certain combination of energy peaks. And it will identify, it'll tell you what it is. It will throw color underneath that peak. Blue is for, that dark blue is for an industrial. It means it's an industrial isotope. And on the far right, it's CS-137. If you see only one peak highlighted and you see only one isotope named, then that's what you're looking at. That's the only thing there. Sometimes there can be multiple isotopes. You'll see both names listed to the right. There is a bar screen that you can go to during the measurement as well. You don't have to do it. People, if you're curious to know, well, mostly what am I looking at? Am I mostly looking at cesium? Am I mostly looking at americium, or any of the others? If you touch the little slider dot in the lower left there and switch over to the bar screen, and this again is during measurement, it will show you some horizontal bars. Again, they will be colored. Again, they will be labeled as to what it is. If there are multiple isotopes, the bar with the longest extension is obviously the one that's emitting the strongest signals, and the others will be displayed in relative intensity to the most energetic of them. The coloring can be, for instance, I mentioned dark blue for industrial, aqua if you're looking at a medical isotope, and some people maybe they know they're going to a hospital and they're having to check or even check debris boxes, and they know from hospital. You'll probably more often than not see aqua. The aqua will show up for things like lutetium-177, or gallium-67, things like that. green, if you see the peak labeled green, that means it's norm. It's norm, and norm stands for naturally occurring radioactive material. So that means that what you're seeing there is something that is a normal organic form of radioactivity. This will usually be assigned to things like radium, which can occur in natural surroundings, or thorium, uranium-238. Also, these are potassium-40 is another one. These are isotopes that occur in nature, and you're just looking at normal, naturally occurring radiation background. If the peak is red, well, it means that there's a peak there. We know there's a peak there because it is significantly greater than the background, and it's fitting into our classification as being worth your attention. But we don't recognize the position that it's occupying. We don't recognize the peak energy, or the energy that it's occupying, that it's centered on. And that may be because we just are looking at our ANSI library. It may be an isotope that's available in one of our secondary or additional libraries, or it may be an isotope that is not part of the ANSI or typical medical, industrial, or norm. And I did forget to. If it's a kind of a magenta color, or sort of purple magenta color, that's a special nuclear material. So SNM, special nuclear material. That is something that you would see if you are really onto something like highly enriched uranium, or low enriched uranium, or plutonium, or neptunium, or other type of fissile elements, special nuclear materials. Hopefully you never ever see those come up. You may briefly see a magenta come up because for a moment it saw a peak at that energy, but it says, oh, well, there's these other here. It's just sharing that same energy line. It's some other isotope that happens to also have an energy peak near where that particular nuclear material has an energy peak. Yada, 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 yap, yap, yap. So 60 seconds is the default time. When you can extend it, in the upper right corner, there's a triangle with a point up and a triangle with the point down. By tapping either of those, you can increase with the point up, decrease with the point down in increments of 10 seconds. This is helpful if, for instance, you've gotten as close as you can. We know there's something there, or I've at least been told I need to measure what's there. Take a longer sample by touching that upper arrow, and you'll see that your total time will start to increase, and say, okay, now I will continue measuring until this much time has elapsed. Pretty much it, I think, on how to do that. Did we want to try and either take a break or perform this would be a good time for a demo?
Yeah, we're almost to the break. We just got a demo and then a quick slide on the event report screen. So yeah, let me go ahead and get this set up again.
Very good. And I hope everyone is still awake and listening, and I sure hope you're getting information from this. Some of you are going to be much farther along in your experience with the SAM 950. A lot of this is information you already know. Maybe what you get out of this is pick up a couple of hints or tips now here and there. But again, we don't know of how many people out there, maybe this is their first time, so we want to make sure everybody's understanding the basics.
Of course.
Cody.
I'm going to go ahead and hit that manual ID button here. Just go ahead and get that started. I do have a quick question to actually talk about during this 60-second elevator ride. I'm wondering,
do you have any isotopes?
Oh yeah, I can go ahead and throw up the source I have. I will have to mute myself because of the alarm, but
yes.
All right.
Okay. But it didn't take very long for the SAM 950 to look at peaks and within a couple seconds say, I know exactly what you've got. And I know that what you've got right now is you have two isotopes. You have cesium-137 and you have cobalt-60. And our statistical confidence is 100%. Now, those of you really into statistics know that there's never really a 100%, and that statistical certainty begins at around 95%. Statistical is called certainty, 95%. I'm just bringing this up to show that the SAM is kind of quite heady and full of itself and believes in certainty. Therefore, we have the 100%. I'm certain that that's what these are. 42 seconds after 60 seconds, measuring the you can also, I think earlier I'd mentioned that you can touch the lower, the x-axis and place a cursor on the x-axis that will show what the energy peak is at a particular channel. You can do the same thing when you are performing measurements. When you're performing a manual ID, you can also take a look and see what the center, what the energy is, for instance, at the center of any one of those peaks. What we wind up with at the end is an event report. And it'll tell you the event number, the date on which it was captured, what time did you capture, who the user was. Again, this is something you can enter in the event setup log. The alarm duration. You can add comments to your report. You can take pictures of your what the sample was that you were measuring. We're not going to go too much into the details of that today. We'll save that maybe for a more advanced course. But the idea is along the lower, you have a microphone, you have a video camera, you have a camera. This is the icons that you can touch if you wish to add any of that media. On the lower left corner, you have an envelope that you would use if you want to transmit this event to a reachback location. We're going to go more detailed. We are covering that today. Next to it, to the right of that, with the radiation circle on it, is how to send it to a RadResponder, or how to send it to your RadResponder account. We'll go into that more detail a little bit after this next break that's coming up. But this is what your event report looks like. And from the event report, you can, in that moment, send a this event to a reachback facility or send this event to RadResponder. I don't know if there was anything left to event report. Those pictures, all of that stuff will be saved as part of the event file. When you go back and pull up the event and want to review it again on the SAM, or if you've loaded it into Peak ID analysis software, you will, the images will also still be attached to that particular spectrum. Take it away, Cody Cole. And let me take a moment here to rehydrate and give you folks a break from listening to me yammer.
Oh, wait, Mark, am I unmuted here?
You are. I hear you just
all
fine.
Right. So yeah, time for our second set of poll questions. No fun ionizing radiation questions. This is just a general overview of if you own the device, plus if you have ever used RadResponder, which is one of the focal points of the next part of the presentation. So I'm going to go ahead and let those fill out a bit and scroll up in chat and see if there were any unanswered questions at this time. That would be good to pass on to Mark. Here's a quick one, Mark. With the alarm sound, that beautiful noise we heard from the SAM 950 when is exposed to a source, is there any way to adjust that audio? Perhaps change the tone or the frequency of the alarm blares?
Yes, you can. There is a, well, I should say yes and no. You can change the sound from, instead of that siren sound that you hear, there's about 7 that you can choose from going into the setup menus. We've got one that's kind of like a bicycle bell. You have another one that's a telephone ringing. And it's a little. By changing it to that, people are a little less likely to become alarmed when an alarm condition has been met. We don't have the ability to adjust the volume. You can't turn it up any higher than it currently is. You can't turn it any lower than it currently is. I'm not 100% certain that we can even turn off the alarm. But we can change this. I may check into that. I would refer you to the manual. Always read the manual, read the full manual, RTFM, as I say, read the full manual. And that information on what the menus contain, how to get to the menus, and how to select menu items is in the manual. If you don't have one, contact us, let us know. We'll certainly send you the most current manual that's printed. And to my recollection, that's probably within maybe the last one or two versions of the current version. There's maybe only one or two differences, but they're not major differences from what you're seeing probably today on your SAM 950. Let's see, do you own... Oh, well, there's a lot of people out there who haven't bought their SAM 950 yet.
Yeah, but it's very exciting to see some of you are planning to.
Maybe they have a SAM 950, they just don't own it.
Oh,
being honest.
Is anybody being tricky in the questions here?
Come on there.
And in terms of RadResponders, looks like we have a pretty even split with some people planning to use it in the future. It's an incredibly powerful tool. I bet Mark would agree. Like in terms of event mapping, it's probably the direct integration between the 950 and the RadResponder is one of the strongest solutions out there. I would opine.
Yeah, RadResponder, by the way, is, if you don't know what it is or you're questioning why would I even care about it, RadResponder is a tool, it's a function that was developed in collaboration with FEMA and the Department of Energy. In fact, the National Nuclear Safety Administration arm of the DOE, Environmental Protection Agency, they all pooled together and developed this one central location nationally where you can send dose rate information, reports from different kinds of devices, different methods for sending them. Mostly, though, they do prefer that you send it on a RadResponder app or a RadResponder account. But this is a way to centralize all of it. So this is what it is. It doesn't cost you anything. You don't have to buy the app, but it's a very helpful tool. And it's a helpful tool nationally for gathering information. If there are surveys to take, if there are emergencies that need to be responded to. But this is a place to save all of that information.
All right, excellent. I think chat's kind of slowed down here, so I think I'm going to go ahead and close the poll in a moment. I do see there is one answer of not sure as a beginning lead. If you got something that looks like this, you do have a SAM 950, but if it is a more complicated question than that, that was a little bit condescending. But we get in touch with us and we can help you figure out if what you're using is a BNC instrument, which is important because we do manage a lot of the repairs and calibrations of our own equipment at our own site. So definitely make sure to confirm that you got one of these. And if you do, then that's great news because it's a great instrument. But I'm going to go ahead and close this. There we go. And I will go ahead and put us back onto the slides.
Okay. Hopefully we're moving at a decent pace, that those of you who are learning this for the first time are keeping up, and that those of you who already know this stuff have either dozed off or decided to maybe wait until the YouTube comes out and get to the end of it and read the important part. We'll see. we're not offended either way. We don't take it personally. The event report. Now, a few moments ago before the poll, Cody was good enough to perform a manual ID. We came up with a report that indicated we had, it identified cesium-137 and cobalt-60. He illustrated, we'll look at these items here. The status bar on the top, of course, is the same status bar that's been with us since the beginning. Status bar left, status bar right. Event information, detected nuclide. Those are all very helpful to know. You can check this as a favorite. Put that up in the box. When you go back through the event log and you see all this long number of events perhaps that you've captured, if it's a favorite, it'll have like an asterisk or an F or something over to the side, so it'll make it much faster for you to find your favorites, the ones that are probably of most important to you. You can add comments, you can add video, you can add audio messages. If you think you made a boo-boo, you can remove the event. That is within your power. Your administrators may want to always know what happened, save everything. But if you are the administrator, you can remove the event at the end of the manual ID. Let's see, anything else about the event report? Suffice it to say, all of this information gets connected to the event. And at that event report, you can do two things besides going to the back button and you've saved it. Or you can also, at that same moment, use Reachback or RadResponder. And we're going to discuss both of those next. One of the key things to remember about RadResponder or Reachback is that both of these are relying on Wi-Fi. So that said, I hope it's not too big of a risk or too much to ask that remember that you can use this in a Wi-Fi network setting. In some emergency conditions, the command center or whoever is coordinating the events for response will probably set up a local Wi-Fi bubble, in which case you would use the event menu, not the event menu. There are menus in the SAM that would allow you to select the particular Wi-Fi network and sign on. The other thing that you can do is if you have your own phone or if you're with somebody else who has their cell phone with them and they're getting pretty decent cell coverage, open a hotspot. Open a Wi-Fi hotspot with somebody else's phone. And I believe that the Wi-Fi hotspot, the person will tell you, hey, here's the name of this network that I've just set up. And then go through your menu set up on the SAM 950, find that network name and connect. You do need Wi-Fi. I just wanted to use that as a start. The other thing that's important with using Reachback or RadResponder is there are a number of setup steps that you really should take the time to prepare ahead of time so that when it comes time, it's all about time. When it's time for you to send that report to either RadResponder or Reachback, everything's ready to go. You just need to really just press one or two buttons and you're done. But for it to be that easy, you do have to do your homework, do some setup. And this is the first thing that we're going to discuss. Earlier, we had told you how to perform background by holding down and pressing the back button to open the setup menu. We're not going to go into too much details yet. Again, there's the manual to consult. But if you scroll to the bottom, you can, if your administrator allows it, can have access to the administrator menu. And in the administrator menu is where you set up a lot of the groundwork for using these two features. And so, in fact, you can just tell your administrator to do all the work. That's their job. To get into the administrator menu, it's not that difficult. The password is 1, 2, 3, 4. So write that down. It's just in case you need to refer back to it. That's the administrator password. Once you're in the administrator menu, you scroll down to email account. And when you press email account, you'll see this screen come up that you're seeing on the right, Reachback account. You will want to fill out all of these. In fact, you have to fill out all of them. You have to fill out the email address of who it is that you want to send this information to. As the sender, you need to establish your email account. Particularly as a sender, you must use a Gmail account. At least at this point, it's optimized for Gmail. I don't know if there's been too much progress in trying to extend it out to things like Yahoo or other private email accounts, but this works very well with Gmail. Almost ubiquitous that Google and Gmail are a part of this so much in your life anyway. The address to whom we send this, the Reachback account address, does not have to be Gmail, but we do recommend that the sender use a Gmail address. Maybe there's one set up for the organization that you are with. Maybe you use somebody's particular Gmail address, and that's always the one that you use. Put in the address, put in the password, step through these functions on the menu. The server is very important, but I would say that we're assuming you're using Gmail. I've not seen too many instances where the server is not going to be smtp.gmail.com. And if you're using an Android-based phone, and if you're using the SSL or the TTL filtering for your encryption, the SSL will be port 465 if you are using a phone that uses the transport layer server, so the TLS encryption. You'll probably put port 587 down there, but those need to be completed, all of those lines completed. When you have done them and you're looking at this screen, and I need to remind you this because I forget sometimes, you have to scroll down even further. There's a little section there called Save. If you just kind of press the back button, well, I've entered all that stuff, go back, you're going to have to do it again. Scroll to the bottom, press Save. You've got that information. You're ready to use Reachback. And so how do we send Reachback? Let's see, do your preparations, make sure you have the Wi-Fi. Email, how to transmit really is pretty straightforward. When you're at the event, and again, this can be at an event that you've chosen from the event log. But what's really cool is you can do this real time after you've completely measured the event, done a manual ID. Lower left corner, there's an envelope icon. Touch the envelope icon, and it will show you, if you have RadResponder also, it will ask you, how do you wish to, you know what? I think not. I think if you press that icon, the envelope icon, it assumes that you're sending Reachback via the email. And so the next thing you should see is the transmitting and sending and transmitting success and okay. It's that simple, as long as you've done your homework and put in the correct and the necessary email settings. That said, from time to time, particularly during the last year or so, we were getting a lot of questions from people who were following the instructions faithfully and still when they would go to press the envelope and say, cannot transmit, please check your settings. And people have checked and rechecked and rechecked, and they probably did everything correct, but we have discovered something that you need to do, again, as part of your, and it's not explicit because it's a kind of a surprise that Google came, but it's one of those tasks that you should do ahead of time. If you go to the next slide, Cody, what we discovered is, let's see, are we going to do the live? Do you want to do that? Before you do that, can we jump, since I broached the topic?
Yeah. Is this what you're looking for?
Yeah.
All right, great.
You can go back and actually do the demo if you want. Google, because you're using Gmail, you probably have a Google account, and Google likes to manage your Google account, whether in fact, whatever. They can. They do it because they can. And one of the account management settings is a security setting. And so you have to change this security setting in order to let the Reachback portion work for the SAM 950. You can only change this on a PC. I don't know why you can't do it on a phone. I've never found an Android phone or any kind of a Google app on a smartphone that will allow you to do this. You will have to go to your PC and prearrange, meaning do this before you ever need to do Reachback. Go to manage my Google account. Open open your Sender Gmail app on your PC. Yes, okay. So whatever Gmail account you're using as the sender, open your account ID, manage your account, scroll near the bottom, and there's a section there for security. Open the security column, and then you scroll down, you'll see something that says less secure app access. Bless their heart, Google's trying to protect you from downloading apps that maybe are not secure. I don't know if sometimes sometimes apps that we don't approve of, but for the SAM 950, there's really only the SAM 950 that you'd like to make available. So pull up security, turn on less secure app access. It's a little confusing. By default, it'll be in the off condition. Move the switch so that it's in the on condition. Save, go back, and the next time that you transmit, I'm going to say very high percentage of the time, that was the bugaboo that was keeping you from sending stuff to Reachback. So it is something that came to our attention. We don't know how to get around it on our side because it's Google, it's Gmail that's trying to protect you. With this knowledge in hand, you can make the informed choice to enable less secure app access. Cody, are you ready for the event and transmit?
Of course. Let me go ahead and set this up. Make sure I'm not muted. All right.
Okay.
Go ahead and.
On your SAM, are we on an event report, a recently captured or a currently captured event report?
Not quite yet, but I sure can get there.
All right.
Go ahead and. Oh, there we go. We're on an event right now, actually.
Okay. So this is the same one. This is the same event screen that you see when you've finished a manual ID. And ostensibly, all Cody has to do is touch that envelope icon in the lower left corner of the screen. And so I ask you to go ahead and do that, Cody.
All right. Email is not set up. We had RadResponder set up, Mark. I don't know what will happen.
Well, it should. Incorrect email. Oh.
Yeah, we set up RadResponder, Mark. So I have that enabled right now.
Okay.
If you want to do that.
I apologize. We have not done that yet on Cody's phone.
All right. I think something just happened with the display during that. This is kind of a unique setup for us. So I'm going to go ahead and see if I can get that fixed up. But
in the meantime, Mark's going to do shadow puppets. Okay.
Go ahead and get that restarted.
Reachback is pretty simple. Again, it's a matter of having the correct information, having an email account to use, knowing the email account to whom you wish to send. Some of the more popular email reachback locations are organizations like Triage is an organization that has an email address. Another is Jackus, I don't know how you pronounce it, but it's like GACCIS. I don't have committed to memory the particulars of who are the sponsors, but they are national. And these are addresses that you can make as the sender. More often than not, what I've seen is that there is a local entity, maybe the county sheriff, maybe the county Department of Emergency Services, but there will typically be someone more local to you that would like to see your event reports first. And so that is probably who you will send to. Ask your organization, to whom should we send our reachback information when we have it. And then Gmail, that's yours. It's all yours. Let's talk a little bit about Reachback. You might as well. Cody, if you're able, if we can move it, let's see, Reachback, we discussed.
I'm almost back here. Sorry, what do you want me to do?
Oh, are you almost done with the email?
Setting up email? No, I'll set up email if you want to continue on to the next slide.
Let's move on to the Reachback. Now, again, reports that events that you've just created, event reports that you've just created, can also be sent to a RadResponder account. This, again, requires you to do your homework and to do details before you try to use it. How to set up? Well, same setup menu I mentioned before. Go down to the same password. Again, 1, 2, 3, 4. I hope you wrote that down. Pardon me. That gets you into the administrator menu. And in the administrator menu, similar to what we saw with Reachback, if you scroll farther down, there's also one there called RadResponder and RadResponder mode. So when you open that up, by default, there's a little checkbox to the right. It's turned off. There's no blue check in it. Put the blue check mark in there by touching it or highlighting it with the cursors and pressing enter. And that enables RadResponder mode. To use RadResponder, you need to have already opened a RadResponder account. So again, this is part of your homework. Go to radresponder.net, I believe, and open and create a RadResponder account. The RadResponder accounts, you may need to let us know if you've set up a new one for a new organization, because those do need to show up on the sponsor list. So let's see, set up your administrator. Oh, password, you already do that, RadResponder. When you do the log in, you must already have a RadResponder account. I was just mentioning that. Let's go to the next slide, if I may request. Okay. Once you've created your user account name, once you've created your password, they will ask, okay, hey, welcome. And do you want to let Sam3 Peekabout have access to your RadResponder account? So, well, of course you do. That's why we did all of this. So press the green area, the green button on the screen that's called a grant. Select your sponsor. Now, for instance, there's a demo organization for people that have not had a chance to maybe your organization hasn't yet completed your RadResponder entry, or you are NORAD Inc. or the California Department of, I don't know who the CDP is. I'm sure someone would know all the alphabet soup there. In my instance, when I would set this up, I would select Berkeley Nucleonics as my sponsor because we as a organization have an account with RadResponder. Press save and then select your event type. I'm not sure what the default is. I think the default is emergency response. That's the top of the list there. We really don't want to be doing that unless we know for a fact we're going to be in a place where we're going out to do an emergency response. So we would prefer that, at least for getting comfortable with this, or if you know that where you're going to use this is exercises, local exercises or practice, select testing and training. You scroll down, touch or highlight that, put the blue dot for testing and training, and again, save that. That is your homework for setting up for RadResponder. And then it finally comes to the point, now you can use RadResponder. If we can get to the next slide, excuse me, take a moment to rehydrate. CDP, thank you. I had asked, what is CDP? The Center for Domestic Preparedness. Of course, they have an account with RadResponder. Thank you for whomever sent that. Oh, Alan, you're the best. Or was that Charles Adams? Oh, it's Charles Adams. Charles, thank you so much. So this time when you finish an event, as we told you, there are two icons in the lower left. One is an envelope. One is got the circular radiation insignia. When you touch that one, it says, hey, RadResponder. It will, if you've already signed in, it shouldn't ask you to sign in. It should immediately go to the part that says RadResponder authorization. Again, touch the green area that says grant. We want to grant Peak About 3 or grant your RadResponder authorization to you. And again, you will get a transmitting sign. Sometimes there'll like be this dark square in the center of the screen that lasts maybe up 5 or 10 seconds. Don't be alarmed. It's something I've seen that's pretty much normal, I guess, now. But eventually you should see success. And you've set now a testing and training event report to your location where your company keeps your folders, and you've stored that event there, and that part is successful. That said, always the caveat. Something that I was noticing in this last year, I'm still kind of working on a solution, is for some reason the icon at the event report, when you're finished and you have the event report, and using that icon will not initiate the RadResponder transmission. It's okay. It's still pretty easy for you to get around. Here's what you do. When you have created an event, and instead of trying to do RadResponder response there, go ahead and hit the back button. It will already have been saved to the event log. And if we go to the next screen, we want to show you how to open the event log. Well, it's the same menu that we've told you about several times today. Touch and hold the back button. Instead of going to the setup menu, touch the top area, touch event log. You will open up the event log. If you want to send the event that you've just recorded, boy, that's going to be easy to find because that's going to be on the top of the list. So always from most current to older is the way it's stacked. Touch and hold that for about 2 seconds. Just touch and hold it. The device will then come back and ask you, well, now, do you want to send this via email or do you want to send this via RadResponder? Touch RadResponder. And hey, we see the same screens again. Grant authorization. We'll see the transmitting and sending signs and success. So Reachback works. If you're having trouble with Reachback, contact us, but we think pretty much take care of that secure or allow less secure apps. Take care of that in your Google account. And then for RadResponder, if currently you're not able to send a RadResponder immediately after capturing an event, worst case, couple of extra button presses. Go back, open the event log, put a long touch, 2-second touch on the event that you want to send, and then the rest is the same. Grant authorization, transmitting, you're done. I'm going to check in with Cody and see what his progress is. We should have done our homework. We did for the RadResponder. We will show you how the RadResponder event works. But how you doing on the Reachback email?
Hello. Can you hear me?
I can.
All right, great. Let's go ahead and get right back into it then. Here we go. Back here, and I have it on the email now. I will show the transmission. A caveat is that I might have typed in my password wrong. I was scrambling to get this set up, but
and on the screen they just show you dots. So
yeah, so let's go ahead and hit transmit. This is the email option.
Transmit and transmit. And
so if it was the correct email, it would go to.
Well, my next question to you is, have you taken the time to go onto your Google account on your PC and enabled the secure less apps?
I have not, Mark, but if I was able to go ahead and do that in a hypothetical, I believe that would solve my problem I'm having here.
I have great confidence that that's all that's needed. If you yourselves, you as participants, encounter problems performing the Reachback or the RadResponder, please give us a call, send us an email, describe for us what you're seeing, send a picture if you can of what you're seeing, and we're pretty good about getting back to you and getting you the answers that you need. And if it's a new one on us, we'll find out. We'll get it solved.
Yep. And here's RadResponder, though, if we want to go right into that.
Oh, all right. So, again, he's on an event log, and he's picking one, and he did the long touch.
Whoop.
No, you're good.
And
press grant.
Grant.
And it's transmitting. There's that little square I was telling you about. That could be anywhere from 5 to 10 seconds sometimes. And success. So Cody successfully sent that particular event there, event number 6, to RadResponder, to the BNC folder, and to our location on the BNC folder at RadResponder. They will eventually, as they screen through their process, see that hey, we have a new entry here. And because it's testing and training, of course, obviously, it's not going to be an emergency situation for them. But again, this is mostly just for your own testing and training anyhow. So that part does work. Okay. And Reachback, very likely we have just a change to make in the Google security account management. We've covered the basics. Again, to get started and get going, you have to do 3 things. You have to turn it on. You have to wait for auto calibration. You have to perform a background. You do those things, and you're ready to search. You're ready to measure. Hopefully, we've covered the details on that enough for you to be able to capture and create your events. We've also shown you how to send them immediately to Reachback locations or to RadResponder. And along the way, I hope we've had a chance to advise you with some tips and tricks that maybe aren't always spelled out, and that these will become part of your lore, and that somehow we've prevented, or at least we've alleviated a potential headache for you sometime down the road. You must be tired of hearing me talk. I'm going to let Cody do some major talking now.
Whew. That was a fantastic presentation, Mark. I think we covered just about every single bell and whistle in the
You said,
SAM. I really wish you didn't give out our super secret administrator password, but it can't be helped. So that's a joke, by the way. It's not.
I'm going to go home and change the security numbers on my luggage.
But anyway, I do have one more delivery to give. Then we'll go to the exit poll and enter a straight up Q&A segment. And what I wanted to present was, let's say you're trying to review the contents of this webinar, this virtual training, and perhaps it's a bit too comprehensive for what you're trying to do. You're just trying to quickly find a certain feature or a tool, and you're clicking around and you're like, here's a part where he whines about his fish or something. We have a lot of courses on our radiation detection equipment online at our BNC Academy. I'll go ahead and put the link in just a moment, but we have courses ranging from a free online training, kind of similar to this, but using images and static videos for the SAM 950 and some of our other radiation units. But let's say you also have more sophisticated questions like, what is a solid state detector and how does it detect neutrons? Or what is the scintillating material doing inside of my SAM 950? We provide paid courses there that for the price, you're receiving a course curated by experts in the industry, supported by all of the equipment that you're seeing here today. So it's a very comprehensive way for you to go ahead and supplement your learning if you do want that. And as a bit of good news, using the code BNC950 for the next 14 days, 2 weeks, so you have a pretty good window to decide, the radiation courses, anything in our nuke series, is completely free to you. So the 48 or so people that I see who have stuck through, who have persevered.
Oh, the attrition rate. Oh, my God.
Oh,
48 of you are left. Oh.
Hey, I mean, that's kind of
Thank
natural.
you. Thank you so much.
Yeah,
and I'm sorry. Thank you, and I'm sorry.
Now you can go through your scintillator course laughing about all the people who left a little bit too early before that code popped up. But with that, I'm going to go ahead and put up the last question, which is more for our sakes, which is just a how did we do? And if you believe we did well, you can put excellent, very good. And of course, we're always open to improvements with these presentations. We do these for you. And the better we are at conferring concise information to you, the better we feel, because a more knowledgeable and a more communicative industry is best for everybody, especially in a field like radiation.
And these are totally anonymous. We have no idea.
Actually, I can look at who's putting in.
Yeah, so you can go back and go, good? You only gave us a good? Oh, well. I'll leave that up to Cody. I don't have that list.
No, we're good. I mean, anything below a good, I will only cast a passive aggressiveness so subtle it cannot be detected even by the highly sensitive SAM 950.
True.
But while this poll is up, I will be going ahead and looking down to see.
We have, I know Alan has been slaving. Alan, thank you so much, by the way, for carrying a load. I'm sure that you've been immersed in providing answers. If you have a question, or if you have a list of questions, Cody, that have not yet been addressed, we'll play Stump the Chump and see what we can come up with here on live webinar.
Just punching away at a few email addresses here in response to a question of where somebody could go for support. And I'm also getting that BNCA link ready. Go ahead and get this. And there we go. All right. Yep. Those are all of our emails. There's a general inquiry line for general support, or if you just want to reach out or probe. I am the BNCA admin. If you have any questions about the courses, I can assist. I can also assist with general nuclear inquiries. If you're looking for the head honcho, the one who's going to give you all the info, that is definitely Mark Slattery. So if you're not sure if the 950 is right for you or right for your environment, he's going to be able to get those answers to you very easily.
I'll certainly do my darndest.
Very easily is the operative word here. What I mean is he'll get it to you in a very nice way. And let's go ahead and see.
David has a good one there. Will we be adding questions and answers to the Q&A? Oh, yeah, I think we do normally do that, don't we, Cody? When people go back to review this, or when we send webinar.
Yeah, of course. I mean, with all the questions here.
All of the questions and the answers to the questions.
Yeah, every question that's being asked right now is very important, valuable to us. It is enhancing the presentation by letting us cover info that's important to you. So that is definitely why we would be interested in putting it onto our BNC website.
And I have a feeling that most of you would like to just simply go have lunch or go do something other than stare at your screen right now. But seeing a pause in the questions, I think that's probably because Alan has done a bang-up job of answering them throughout. And Cody, you're the guy. We'll see. Oh, wait a minute. We've got something new coming in here. Eduardo, you're very welcome. And
it looks like somebody accidentally truncated a message there. Adelia, if you want to go ahead and get that full message, we'll hang on a bit so that you're able to see.
Yeah, maybe I don't know what I want the first. If the second part is you, I don't know. I don't want to know what the first part is.
Maybe it's you space rock.
Okay, you're right. Yes, it could be.
And you would want to read that.
Yeah, or space you, which is, yeah. Sorry, I can't help it. That's the way my brain works.
Yeah, I do say we have one could use improvements. That's exciting to us. Always good to get concrete feedback. So feel free to use my email there. I am Cody Cole, so I am c.cole@berkeleynucleonics.com. Feel free to send in candid feedback on the presentation. I will not cry, I promise. If you have anger or wrath, I'm sure, actually, I'm pretty confident that this went exactly how we envisioned it. We're very excited to have this live recording finished and to have this virtual training be available in perpetuity. I mean, this is great.
I have completely lost track of time. My God.
Yeah.
Has actually been 2.5 hours?
It has been 2.5 hours. We're nearing the length of a Marvel movie.
Well, all right then. We're looking at the bottom of the hour. We are still we're still going, but I will leave that up to the people behind the curtains who are making all this magic possible. As
all right,
how we will proceed.
Yeah, of course, Mark. And I think this is. Are there any limits on the BNC 950 code? Yes, there's the 2-week limitation. It only works for the nuclear courses. And if you get the course for free using the code within that 2 weeks, it is basically yours to use on that BNCA account. So definitely a good thing to consider, and just go ahead and pick up while you can. There are a limited amount of usages set to the coupon code, but anybody who misses out can always email me. We're not extremely stringent. We're not going to keep you out of information that you're actively looking for. So just let me know and I'll try to get something sorted out for you. And with that last bit of appeal to customer support, I think we're all finished here. Mark, any parting words?
Thank you, everybody. Thanks for those who hung in. It will be interesting to go back over the record and see at what rate people were dropping off.
Don't worry about it, Mark.
But because I'll know that's the section that needs working on. Thank you all for your time. I hope you've gotten a lot out of this. This is our first attempt at trying to do an actual training via the webinar, so this has been useful for us as well. Thanks.
All right. And let's go ahead, Mia, and pause the presentation. Thank you, everybody, and have a great day.